Hello friends, this is Sagar Burde. We are dealing with electrical motor drives. Today we will be discussing about selection of motor power ratings. The power rating of a motor for a particular application must be carefully chosen to achieve economy as well as reliability. The use of a motor having insufficient rating, either it fails to drive the load at its the normal productive level, or it lowers the overall productivity and reliability through frequent maintenance as the frequent damages happen, and shutdowns due to overloading of the motor. On the other hand, if the power rating is decided very liberally, then the extra initial cost and extra loss of energy due to the operation below rated power makes the choice very uneconomical. Further, induction motors and synchronous motors, these two operate at a very low power factor when operating the below rated power. So, when a motor operates, heat is produced due to the losses within the machine and its temperature rises. As the temperature increases beyond the surrounding temperature, or say ambient temperature, a portion of heat produced flows out of the machine towards the surrounding medium. The amount of outflow of heat is a function of temperature rise of motor above the ambient temperature. As motor temperature rises, the heat outflow increases and equilibrium ultimately sets in when the heat generated becomes equal to heat dissipated into the surrounding medium. Now, say motor temperature reaches a steady state value when these two are equal, when the production of the rise of temperature within the machine is equal to dissipated to the surrounding medium. When these two are equal, then motor temperature reaches the steady state value. This steady state temperature depends on the power loss. This in turn depends on the output power of the machine. Since temperature rise has a direct relationship with the output power, and in electrical drives we term it as thermal loading. Steady state temperature, it is not the same at various parts of the machine. As we know, the machine consists of various parts and the different materials are used, so this is not same for all the parts. It is usually highest in the windings because loss density in conductor is high, and also the dissipation is low in the windings. Since the conductors which are wrapped in insulating material are partly embedded in slots, and thus these are not directly exposed to the cooling air. Among the various materials used in the machine, the insulation has very low temperature limit, lowest temperature limit. Depending on the temperature limits, the insulating materials which are employed in designing of electrical machinery are divided into the following classes: the gamma, A, E, B, F, H and C. The table shows the list of the classes of electrical insulation materials as well as the temperature limits of these insulations. When operating for a specific application, The motor rating should be carefully chosen to ensure that the insulation temperature never exceeds the set value. Otherwise, either it will lead to its immediate thermal breakdown, which causes a short circuit and damages the winding, or it will lead to the deterioration of its quality, which results again thermal breakdown in the near future. For loads which are which operate at a constant power and speed, you can determine the motor power rating very easily, and it is a straightforward process. But only a few load operate at a constant speed and power. On the other hand, most of the load operate at variable power and speed, and the pattern of these variations are different for different applications. So you cannot generalize it. These are different for different applications. So in general, the selection of motor power rating has in general three objectives. It has three objectives. First one, to obtain a suitable thermal model for the machine which can be utilized in calculation of motor ratings for different classes of motor duties. Second, categorization of load variation with time into certain standard categories which are termed as the classes of duty of motors. To present methods for calculating motor ratings for various classes of duty. So these are the three objectives which are taken into consideration while selecting a motor power rating for an electrical drive. In the next session, we will be discussing about thermal model of motor for heating and cooling. Then we will go to classes of motor duty. Thank you.